A block of mass 5 kg which is at rest can slide along this smooth track. A man pulls the block through a rope having a tension of 10 Newton, which makes an angle of 60 degree with the horizontal. If the block moves 5 meter along the horizontal, the amount of work done by the tension is given in the problem is this situation. Man is applying a force on the block through a rope. By the tension of the rope, because of the tension of the rope, the block moved a distance of 5 meters. Now, before we move further in this question, first of all, watch this. Work done is equal to Fs cos theta, right? So here, if this is the direction of force and this is the direction of displacement and this is theta, right? If you break down the force into components, then the horizontal component will be F cos theta, F cos theta, and the vertical component will be F sin theta, right? Now, if you carefully observe the formula, you can say that work done is equal to S multiplied by F cos theta. I'm doing nothing, I'm just rearranging it, right? So work done is equal to S multiplied by F cos theta. And what is F cos theta? F cos theta is the component of force along the direction of displacement, right? So work done is basically the product of displacement and the component of force along the direction of displacement, right? Now in this question, in this situation, if we look at the horizontal component, it will be T cos 60 degree, right? Here we have the tension which is equal to 10 Newton. So we can say that if the tension is making an angle of 60 degree with the horizontal, this will be 60 degree, T cos 60 degree, and here we have T sin 60 degree, right? Fine. Vertical component will be T sin 60 and horizontal component is T cos 60, and we don't need to take care of the vertical component. Why? Because there is no movement, there is no displacement in vertical direction. We just need to take care of that component of force which is along the displacement of the particle, right? And that is why the work done will be Tx into S, x component of tension multiplied by displacement. So let's do that quickly. X component is T cos 60 multiplied by the displacement. Tension is 10. Cos 60 is 1 by 2 and the displacement is 5. Or we can straight away write the x component which is 5 Newton. So 5 into 5, the answer will be, the work done will be 25 joules, right? Understood? Got it? The concept? And finally, the correct option for this question will be option A. A constant force F is equal to 2I cap minus 3J cap plus K cap is applied on a ball to displace it from R1, which is I plus J, to R2, which is 4I cap plus 3J cap. And it is asking that which of the following statements is true. Force and displacement are perpendicular to each other and work done by force is equal to 0. Force displacement are parallel and work done is 0. Force and displacement are anti-parallel to each other and work done is 0. Force and displacement are perpendicular to each other and work done by force is not equal to 0. So basically these are the four options, and and according to the data given in the question, we have to tick mark the correct one. So here we have the situation. We have a ball which has been applied a force of 2I cap minus 3J cap plus K cap. 2I cap minus 3J cap plus K cap. And because of the application of this force, the ball moved to this final position. Initial position is I plus J. Final position is 4I cap plus 3J cap, and the force was 2I cap minus 3J cap plus K cap. Force is given, initial position vector is given, final position vector is given. So formula will be work done is equal to F dot S. And we have to tell that which of those statements were correct. Basically, in all of the options, it was asking the direction of force and displacement, that either they are parallel, anti-parallel, perpendicular, right? And if the work done is 0 or not 0. Two things we have to calculate. So here, first of all, we need to calculate the displacement. Displacement will be R2 minus R1, right? R2 is I cap, not I cap, 4I cap plus 3J cap minus I cap plus J cap, right? Finally, it will be 3I cap plus 2J cap. This is the displacement. Now comes the point of calculation of direction. What is the angle between them, right? So how should we do it? Work done is equal to, here I have already written, so I should write here. Work done is equal to F dot S. So we can write work done is equal to Fs cos theta, right? Or from here we can say that if this is equation 1, this is 2, it will be F dot S is equal to Fs cos theta, correct? And from here we can say that cos theta is equal to F dot S divided by magnitude of S and magnitude of displacement, right? So from here we have got that cos theta is equal to F dot S, vector F dot vector S divided by magnitude of F into magnitude of displacement. F is equal to 2I cap minus 3J cap plus K cap. What is the displacement? 3I cap plus 2J cap. Let's place it. So cos theta is equal to F 2I cap minus 3J cap plus K cap dot 3I cap plus 2J cap divided by the magnitude of F into magnitude of S. Right now, we don't need to take care of the magnitude part. Why? Because if the numerator is 0, then cos theta is 0, right? So first of all, we need to arrive at that, whether the numerator is 0 or not 0, correct? All right. So let's do that. First of all, I cap, coefficient of I cap, 2 into 3, 6. Coefficient of J cap, minus 6. And coefficient of K cap, plus 0. Divided by magnitude of F into magnitude of S. And straight away we can say that this is coming out as 0. So if cos theta is 0, then theta is equal to 90 degrees. So what does that mean? Cos theta is equal to 0, and finally we have got theta is equal to 90 degree. What does that mean? This means that the angle between the force vector and the displacement vector is 90 degree, right? If theta is 90 degree, then the angle between force and displacement is 90 degrees. So we can say that these two, force and displacement, are perpendicular to each other. Now imagine, if they are perpendicular to each other, then work done is equal to Fs cos theta. Work done is equal to Fs cos theta, right? And since cos theta is 0, work done will be 0, right? So we have got two things. Force and displacement are perpendicular to each other, and because of that, the work done is 0. Anytime, whenever the force and displacement are perpendicular to each other, theta is 90. If theta is 90, cos theta is 0. If cos theta is 0, work done is 0. Correct? Now moving on to the option, we have got all the things which we need for the option. Yeah. So option A is the correct option for this question, where it says force and displacement are perpendicular to each other and work done by the force is equal to 0. So Option A is the correct option for this question. In the arrangement as shown, tension T2 is. In this arrangement, we have to find the magnitude of tension T2. First of all, let's analyze the diagram. Let's analyze the arrangement. Here, we have been given that this system, this arrangement is at rest. Or, in other words, in the language of physics, this system is at a mechanical equilibrium. Correct? It is not moving. Since it is not moving, at any point, the forces should be balanced. Correct? Or the forces should be in equilibrium. Correct? So, if we are considering any point in this arrangement, we can balance all the forces in horizontal and vertical direction. Right? Am I right? Yes? Okay. So, how shall we proceed? First of all, we should draw the free body diagram. That is the first step. Correct? All right. So, here, let's say we have tension T in this rope. Okay. So, first of all, we are drawing the free body diagram of 10 kg. Okay. There is a gravitational force to start with, which is 10 g. Correct. The rope is applying a tension T on the block. That's it. Two forces on the block of 10 kg. Now coming to the pulley. Let's say here we have tension T again at this point also. Since the rope is same, tension will be same. All right. Any other force on the pulley? Yes. On the top there is a rope. Let's say it is applying a force F, which is also a tension. Since it's a rope, it's also a tension force, but we are denoting it with F. Okay. Now, for the block, we can say that T is equal to 10 g or T is equal to 100 Newton. Correct? Value of tension we have got. Now, for the pulley, we can say F is equal to 2T. Right? We are just balancing the forces. Correct? So F is equal to 2T. Let's say this is the second equation and the first is this equation. Correct? So we have got two things. Tension we have assumed as T in this rope from which the block is hanging, and the magnitude is 100 Newton. And another equation we have got F is equal to 2T, and F is nothing but tension in one of the rope. All right. Now moving on to a point, this junction point. Let's say I define it as O. At this point, at O, we are going to balance the forces, because since the arrangement is at rest, it is at equilibrium. Correct? Now, at point O, let's draw the forces. Here we have tension T2. In this direction, we have tension T1. Any other force? Yes. Since this is a rope, this is a rope, right? So there should be a tension, and we have taken the magnitude of tension in this rope as F. Correct? And the magnitude of F is equal to twice the tension T, where T is the tension in this rope. Correct? We have arrived at this equation. F is equal to 2T. So we can say here a force F is acting in downward direction at this point. Now these are the forces acting at this point. Let's resolve. All right. Let's resolve and balance. Since this is 30 degree, we can say this angle is also 30 degree. Correct? Alternate interior angles. Here also we can say this is 60 degrees. Right? Okay. So let's resolve into components. Here we have 30 degree. So we can say this will be T2 cos 30 degree. In vertical direction, this will be T2 sine 30 degree. Right? Okay. Here, since this is 60 degrees, this is T1 cos 60 degrees. Correct? And in vertical direction, I'm writing it here, T1 sine 60 degrees. Correct? Done. Let's see it clearly. Here in the diagram you can see it clearly. We have two upward forces. We have two forces in positive y direction, which is T1 sine 60 degrees plus T2 sine 30 degree. In horizontal direction, in negative x, you can say, let's say this is positive y and this is positive x. Okay, that is understood. So in negative x direction, T1 cos 60 degree. In positive x direction, this is T2 cos 30 degrees. And there is another force in downward direction, which is F, which is equal to 2T, right? So first of all, horizontal equilibrium. In horizontal direction, we can say T1 cos 60 degrees is equal to T2 cos 30 degrees, right? Let's place the values. Cos 60 is 1 by 2, so T1 by 2 is equal to T2 root 3 by 2. This is the first equation, correct? For vertical equilibrium, in positive y direction, we have T1 sine 60 degrees plus T2 sine 30 degrees, which is equal to F, and F is 2T. F is 2T. And if you remember, we have found out that T is equal to 100 Newton, right? We have calculated 10G, which is 100 Newton. Okay, so let's solve it. Here we have T1 root 3 by 2 plus T2 by 2 is equal to, if we place the magnitude of T, we can say this is 200. Now placing the value of T1 in equation 2 from equation 1, right? Okay, let's do that. What will be T1? Let's cancel this off. T1 will be equal to root 3 T2. Root 3 T2, right? Into root 3 by 2 plus T2 by 2 equals to 200. And if you will solve it, you will get 2T2 is equal to 200. And finally, T2 is equal to 100 Newton. We have got the magnitude of T2 and this has been asked in the problem. So let's see the options. Yes, option B is equal to 100 Newton, and that is why option B is the correct answer for this question. Now let's look at this question on pulley block system. Two blocks are connected over a massless pulley as shown in figure. The mass of block A is 10 kgs and coefficient of kinetic friction is 0.2. Block A slides down the incline at constant speed. Now what is the mass of block B? In this question, the situation is something like this. Block A is sliding down the incline with a constant speed. What does that mean? If the block is moving with constant speed, then the net force on this block should be 0. Why? From Newton's first law, right? So the net force on block A should be 0. We are clear about that. Now moving on to block B. Since block B is connected to block A by a rope, then from the principle of constrained motion, block B is also moving upwards with the same constant speed, right? So we can say from the same law, the net force on block B also should be 0. So net force on A should be 0. Net force on B should be 0. These are the two equations we have to frame and calculate the mass of the block B. But for that, we have to draw the free body diagrams, right? Starting from block A. On block A, there are 4 forces acting. First, tension T, right? Second, coefficient of kinetic friction. Why kinetic friction? Because the block is actually moving. There is a relative motion between block and the inclined plane. There is the normal reaction, and here we have mg. Now since we have to choose one coordinate axis, so let's resolve mg into its two components. Given the angle of incline is 30 degree, so we can say here we have mag sine 30 degrees and mag cos 30 degrees perpendicular to the plane, right? Block A done. We have drawn the free body diagram of block A. Moving on to block B. Two forces, right? One, tension, which has been applied by the rope. Another, mg, mbg, right? So we have to balance the forces. Why? Because net force is zero on both the blocks. Why? Because both of them are moving with constant speed. Correct? So shall we write the equations? Yes. For block B, T is equal to mbg. For block A, in vertical direction we can say N is equal to mag cos 30 degrees. Right? In the x direction we can say mag sine 30 degrees is equal to T plus mu k times N. First equation, second equation, third equation, right? Now these are the three equations. We have to solve them and find the magnitude of mass of block B. Okay, all right. So let's solve them. Here we have one more equation. N is equal to mag cos 30 degrees. Let's focus on equation number 2 and let's substitute the values. Ma, let's place the mass here itself. Ma is 10, right? Mass of block A is 10 kg. G is 10. Sine 30 is 1 by 2 minus T. From equation 1, T is mbg. mbg minus mu k. Coefficient of kinetic friction is given 0.2 in the question. Normal reaction from this equation is mag cos 30 degrees. What is MA? MA is 10. What is G? It is 10. Cos 30 degrees is root 3 by 2. Correct? Moving on. This will be 2 5s are 10. 50 minus 10 MB. Right? G is equal to 10 meters per second square minus 2 goes off with 0.1. So here we have 10 root 3 equals to 0. Now from here, if you calculate the mass of block B, you will get 3.3 kgs. First of all, we have to clear out that net force on both the blocks is 0, right? Then we have to draw the free body diagrams. Then we have to frame the equations, correct? And we have to equate the net force on both of them to 0. From there, we got the equations, then substitute the values and get the answer, correct? So MB is equal to 3.3 kgs, and with that, option B is the correct option for this question. A ball is released from the top of a tower. The ratio of work done by force of gravity in first second, second second, and third second of the motion of ball is, right? So here is a ball. It has been released from the top of a tower. Now, if it has been released, that means it is moving under the effect of gravitational force. Correct? It is moving under the effect of gravitational force. In which direction? In the same direction as the force. Correct? Now we have the formula of work done as dot product of force and displacement. And if we expand it, this will be Fs cos theta, where theta is the angle between displacement and force vector. Correct? In this case, theta looks like to be 0 degree. Right? So let's place it. This will be Fs cos 0. And finally, work done is product of force and displacement. Now we know the force. Force is mg. This is not going to change for any of the durations given, right? So force is same, but the displacement will be different in first second, second second, and the third second, correct? So we have to figure out the displacement, and I know that you remember the formula, correct? This was the formula for nth second displacement, right? So what you're waiting for? Let's calculate. Displacement for the first second, S1. Now u is 0. U is 0 for all of them. Why? Because the ball is released. And if the ball is released, initial velocity is 0. So finally, this will come out as a by 2, 2n minus 1, right? Because u is 0. So S1 is equal to A. A is G, which is 10. So 10 by 2 into 2n minus 1. 2 into 1 minus 1. And finally, this will give you 5 meters, correct? For S2, let's calculate quickly. 10 by 2, 2 into 2 minus 1. This will be 15 meters, correct? S3 is 10 by 2, 2 into 3 minus 1, and finally this is 25 meters. Now we have the displacement, which are of course different. For the first second, it is 5 meters. For the second, it is 15 meters. And for the third one, it is 25 meters. Now is the time to calculate the work done. Work done is equal to Fs. Just now, we have figured out that work done is a simple and exact product of force and displacement, right? Force is mg everywhere, right? And here we can write Sn, correct? So W1 is to W2 is to W3. You have to find this ratio, right? This can be written as mg S1 is to mg S2 is to mg S3, right? Just now we have figured out S1, S2 and S3. What are they? S1 is 5, so this is 5 mg. S2 is 15, so this is 15 mg. And finally this is 25 mg. And if you simplify it, this ratio will turn out to be 1 is to 3 is to 5. All are multiple of 5, right? So the ratio will be 1 is to 3 is to 5. And since we have arrived at the answer, let's move on to the option. Option C is the correct answer for this question.